Hi everyone, I'm Swati,
And I'm Cal.
and we're part of the Columbia Space Initiative SPOCS team, and today we're here to present a little bit about the International Space Station and conducting scientific research aboard the space station. So let's begin really quickly with an overview of what exactly the International Space Station is and what it's used for. So it's essentially a really large spacecraft that orbits around Earth. It houses astronauts along with several scientific laboratories used for a number of different research questions. It's also the culmination of a huge international collaboration between over 16 countries, and it orbits approximately 250 miles above Earth. And it's primarily used by NASA and space agencies all across the world to learn about what it's like to live and work in space, which we hope can help us understand the consequences and effects of space for future spaceflight to Mars, the moon, and even beyond. And the space station itself is about as big as a house with 5 bedrooms. It's got 2 bathrooms, a gym, and a big bay window. And it houses about 6 people at any one time and weighs about 1 million pounds. And on the side of the space station, you can see these very prominent solar arrays. They collect energy from the sun and basically turn that sunlight into electricity. Now let's learn a little bit about the history of the space station.
So some basic history of the ISS. It all started in 1984 when Reagan proposed the idea of the ISS as an international collaboration and a permanently inhabited space station. And so to make this happen, the US made agreements with 14 other countries and later Russia in 1993. The first segment was actually launched by Russia in 1998, and it provided electrical power, storage, propulsion, and general guidance during the initial stages of assembly of the ISS. And 2 years later, astronauts could actually begin residing on the station, so beginning in 2000. The station has progressed since then, with the US model being added in 2001 to include plenty of research facilities and support a lot more astronauts. And so we have a video here to kind of talk about life on the ISS and what that looks like.
So this is Node 2. This is a really cool module. Of course, most of these modules you'll see they have 4 sides and they're put together. That way we could sort of work on a flat plane, either a wall, a floor, another wall, or the ceiling. But you know, again, all you have to do is turn yourself and your reference changes. The reason I'm bringing that up is because this is where 4 out of 6 of us sleep. And so people always ask about sleeping in space. Do you lie down? Are you in a bed? Not really, because it doesn't matter. You don't really have the sensation of lying down. You just sit in your sleeping bag. So here's one sleep station right here. I'm going in right now. You can follow me if you want. So I'm inside. It's sort of like a little phone booth, but it's pretty comfy. I've got a sleeping bag right here that we sleep in, so we don't have sort of like a little bit of a cover. We don't fly all over the place. But you know, you can sleep in any orientation. I have it sleeping, feeling like I'm standing up right now, but like you saw, I'm on the floor. But it doesn't matter if I turn over and I sleep upside down. I can't have it. I don't have any sensation in my head that tells me that I'm upside down, so it really doesn't matter. The sleep station is also like a little office. We've got a computer in here. As you can see, we've got a couple little toys. I've got some books. I've got some clothes and other things that make it sort of like home. I'm coming out. And just for reference, that's one sleep station. This one's another, right here. There's one on the ceiling, if you want to call it, right here. And then there's a 4th on the other wall over here. So all of us sleep in a little bit of a circle. All right, come on back. There's more to show you. I know that there's some questions about how to use the bathroom, and how do you actually live in space like normal, like at home. I mentioned real quickly about getting up in the morning and brushing your teeth and washing your face. Well, how do you do that? Well, here is the bathroom, essentially. You get up in the morning, and we have a little kit, and it has all the essential things that you need, like your toothbrush and toothpaste and brush. See how much better the brush makes my hair look? I'm just joking. It still stands up straight. It doesn't matter where you are. It's always going to stand up straight while you're up in space. A lot of people ask about toothbrush and toothpaste. So, luckily enough, toothpaste, you can do it upside right this way, is sticky, and so it sticks to your toothbrush. No problem. Another cool thing is that water sticks to your toothbrush too. If you can see it, I'll have some water come out. The water is pretty neat up in space. It'll stick to your toothbrush, and it will make a big bubble. And that's just by surface tension. And then you can drink it. So a lot of people ask about what do you do with the toothpaste after you brush your teeth. Two options. Swallow it, and it's sort of like mouthwash, but it tastes a little gross. Or you can just spit it out in a paper towel, and then you don't have to worry about it. Swallowing thing I wouldn't recommend at home. I'm only up here for 4 months, so it's not that bad. One of the most pressing questions about living in space, of course, is the bathroom. So let's take a look at that little piece of.
So we'll cut the video off here just for the sake of time, but as you can see, that's a pretty good overview of sort of some of the details of living and sleeping and brushing your teeth in space and how it's different in microgravity. So we've talked a lot about living in space, but of course astronauts spend most of their time on the space station running different kinds of experiments. And so we wanted to walk you through a couple of different experiments that kind of exhibit the wide range of different things that can be studied on the space station. So as you can see here on the left is the ZeroG Kitchen. So this was an experiment to basically see if we can bake cookies on the International Space Station. And the idea is that on Earth, when we're baking, we use a lot of these leavening agents. So things like baking powder and baking soda to allow our dough to rise. And even things like yeast, which sort of give our dough a lot of volume. It was unclear if these sort of leavening agents and different things would still allow dough to rise in microgravity when there's not that same sort of gravitational experience happening. And so as a result, they created the ZeroG Kitchen experiment. The point was to study these sorts of things along with the shape of the cookie spread during the baking process. And as you can see in the image over here, this ZeroG Kitchen is sort of circularly shaped. It's actually only sized to fit one cookie at a time for baking, which is very different than the ovens that we see here on Earth, where we can, of course, bake trays and trays of cookies at the same time. But they do bake for 15 to 20 minutes, pretty similar to how we bake cookies here on Earth. One really fun fact about the cookies that they actually ended up baking, they ended up using the famous formula from the DoubleTree Hotel, as you can see by the tin of the cookies over here. And I guess another additional tidbit is that even though the cookies were able to be successfully baked in space, they had to be brought back to Earth and studied, so the astronauts weren't actually allowed to eat them at the time.
Yeah, and another long-running experiment is the Vegetable Production System, or the ISS Space Garden. And so the Space Garden serves two purposes. One, it helps NASA study plant growth in microgravity, and two, it adds fresh food to the astronauts' diet. And so what's really interesting is how the plants are grown in the Space Garden. And so they're grown in these pillows, which are filled with a clay-based growth media and a fertilizer that's tailored to the ISS conditions. And so these pillows distribute water, nutrients, and air to the plants. So as you can see in that picture in the bottom right, they're mounted on that surface there, and each pillow typically holds up to 6 plants. And so many experiments have been done with the space garden, and some of these experiments have been centered around how these plants grow. On Earth, plants typically rely on light and gravity to guide the direction of their growth. And so in the absence of these factors in space, astronauts are studying what other environmental factors dictate or influence plant growth. And so the vegetable production system has been a huge success. They've been able to grow 3 types of lettuce, cabbage, kale, and plenty of other vegetables, which are both eaten by the astronauts and returned to Earth for analysis.
Okay, so we can see that there are many, many different kinds of things that we're interested in studying on the space station. But one thing that we have to keep in mind is when we actually are designing experiments, there are a lot of things that sort of constrain the ways that we can create these experiments in order to be able to be conducted on the space station. And so a couple of these constraints to go over right now. The first and most important is probably the microgravity environment. So even things that we might take for granted, for example, watering plants, we can't simply use a watering can and sort of tip the can and expect the water to flow downward. As we saw in the video with astronaut Sunita Williams, you can see that water actually ends up sort of coagulating into little blobs in the microgravity environment, and so you can't use these same sort of mechanisms. And so redesigning experiments to sort of not rely on gravity and gravitational effects is one really important thing for space station science. Another thing is the limitation of the electricity. So of course, the International Space Station receives energy through the solar power from the large solar panels that are produced. But of course, a lot of this electricity is utilized for different life control systems and different things like that on the space station. And so things like keeping the lights on, keeping the temperature comfortable for the astronauts. And so the actual electricity sometimes allocated for certain experiments might be a little lower than the electricity that we'd be afforded by on Earth when we're able to plug things into wall outlets and things like that. A third and very important constraint for biological projects are thinking about contamination prevention. And so when we think about sending things like bacteria or potentially pathogenic microorganisms to space, we of course don't want those specimens to be introduced to the astronauts, especially when they're in an isolated environment like the space station where there's not exactly quick access to a lot of the specialized medical technology that we have here on Earth. And so in order for us to prevent stuff like this from happening, we have to be very careful about keeping surfaces clean and contamination prevented. So as you can see in the image here on the top right, there's an astronaut working in a glove box. And this, of course, is basically a large containment isolation chamber with 2 little slots that have a glove insert for the astronauts to slide their hands into. And this allows for the specimens to be completely isolated from the astronauts, but still allows the astronauts the dexterity and mobility that they would usually have when they're able to pick up and touch their different experimental items. So these are a couple of the important constraints to think about.
Yeah, and another constraint is that payloads often have limited space, just given the space constraints of the ISS. So in the bottom left, you can see an astronaut juggling 3 payloads, and you can tell how small they are relative to the astronaut. And finally, these payloads often must be autonomous, and that means that they have to be functional without any astronaut interaction. And so kind of considering these constraints, we're actually working on building a payload as part of our project. And so our team has been working around constraints such as these in designing our experiment. And so for example, our payload is only allotted 5 volts and 10 by 10 by 15 centimeters of space, and it has to be completely autonomous. And so these are some of the constraints that astronauts consider and that we consider in designing experiments for the ISS.
Okay, so these are a lot of the important sort of considerations and history of the space station and the science that runs aboard the space station. We hope that you learned a lot from this description of the science that runs on the space station, and we hope to see great space station science and space exploration science in the years to come. Thank you.